Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan bin Roslim. So, my title is Experimental Study on Heat Generation in the High-Speed Turning of Pneumonic C263 Alloy using Cryogenic Coolant. My supervisor is IR Dr. Muhammad Rizwan bin Jamli, while my co-supervisor is PM Dr. Muhammad Amri bin Sulaiman. Nickel-based alloy that will be used in this experiment is the pneumonic C263, are widely used in aerospace and high-temperature application products. The widely applied area result from the alloy's excellent mechanical and chemical properties at elevated temperature. Nevertheless, these properties make the alloys to be categorized as extremely difficult to machine, as the extreme heat generated during material removal due to its low thermal conductivity affects the cutting tool wear progression and machine component surface integrity and its fatigue life. In this experiment, liquid carbon dioxide will be utilized as the cryogenic coolant that has a lower cooling capacity, thus reduce the temperature variation, resulting in less work hardening and slower wear development, rendering it suitable for use in cutting hard alloy. For the problem statement for this research, the mnemonic C263 suffers poor machinability as its own low thermal diffusibility, high strength at higher temperature, propensity to harden, the presence of coarse and stiff particles in microstructure, and a chemical affinity toward cutting tool material. Other than that, at high temperature, the elastic modulus of nickel-based alloy decreases. The rebound degree of the process surface in cutting is greater, and the contact stress is also increased. Hence, in order to reduce the temperature, cryogenic coolant has been introduced to overcome the difficulties. The objective for this research is, first, to investigate the effect of carbon dioxide cryogenic coolant on the cutting temperature and tool wear mechanism using various cutting parameters. Second, to determine the optimum and validate the cutting condition in high-speed turning of pneumonic C263 alloy. Finally, to establish mathematical model for tool life and optimum cutting with different cooling conditions. The scope for this research, first, it is the single cutting machines using CNC lathe has ST20 and will be focused on the cooling strategy of the pneumonic C263. Next, this experiment will be performed under cryogenic coolant condition by using liquid carbon dioxide. Next, cutting speed, feed rates, and depth of cut will be set as the parameter in this experiment. Response surface methodology, which is RSM, will be used to determine the optimum cutting parameter in the study, tool wear and tool life as the responses. For the literature review part, Prashant as the Dev written in his article with the title of An Optimal Approach for Improving the Machinability of Pneumonic C263 Superalloy During Cryogenic Assisted Turning, said that the best surface finish is achieved at the lowest feed rate and the highest cutting speed combination. The cryogenic holding time and the cryogenic temperature values are significant on the surface roughness value. Next, K. Nimel Somaros also written in his article that machining investigation of pneumonic ATA superalloy under cryogenic carbon dioxide as coolant using PVD TAIN and TIN coated tool at 45-degree nozzle angle find out that a cryogenic cooling approach decreased the tool wear due to the low temperature of the liquid carbon dioxide steam. The two-way with liquid carbon dioxide machining reduced 28 to 43% and 15 to 23% over wet and MQL. Two-way analysis by SAM image revealed that adhesion and abrasion were less in cryogenic cooling compared to the other cooling strategies. Other than that, S. Jaubani also written in an article with the title of Comparison between cryogenic coolant effect on tool wear and surface integrity in finish turning of Inconel 718. Find out that liquid carbon dioxide cooling strategy is the most appropriate since it is able to withstand 15 minutes with acceptable tool wear and produce a better surface integrity than conventional and liquid nitrogen condition. From the literature review, we also find the the best parameter based on this article which written by Person S. Jeddah and S. Jabani has been written in the findings. For the metallurgy part, first of all, the preparation of experimental tool, which to get the supply of the workpiece and the insert. Next, to design of experimental using RSM to generate experimental run based on the cutting parameter that given. Next, the experimental work will look after the tool life, wear progression, surface roughness, and heat generated. The cutting tool material is used a type of carbide insert of ISO designation CNGG 12048 SGF will be used for the machining experiment. For the machining test, all the machining experiment will carry out on a CNC lathe has ST20 that has a continuous variable spindle speed. The cutting speed are set at 120, 170 and 220 meter per minute, while the feed rate are set at 0.1, 0.15 and 0.2 millimeter per revolution, and the depth of cut being set at 0.4, 0.5 and 0.6 millimeter respectively. Then, the experiments are carried out in cryogenic liquid CO2, conventional flooded coolant and dry condition. The mathematical modeling of the tool life and surface roughness will be generated and will be validated using the validation test, and after being validated, we will be analyzed using the EDX and SEM machine. After all, we get the result. The report writing will be the final step of this experiment. Finally, for the expected result. For this research, we are expected to come up with the optimized parameter in which the help of the liquid carbon dioxide as the coolant in the machining of the mnemonic C263 that will increase the machinability of the alloy itself other than to improve the surface roughness and the tool life to be increased. That is all from me. Thank you.